this module, we will examine some typical fire and sound-rated internal wall systems and how they perform, and also what measures can be taken to improve performance above minimum code requirements. The two main timber wall construction system approaches are either lightweight timber systems or massive timber systems. The minimum NCC sound and fire requirements for walls are as follows. For Class 2 and 3 residential buildings and Class 5 office buildings, an airborne sound rating greater than 50 and an FRL of 90-90-90 for Class 2 and 3 residential buildings for both general and massive systems. And for Class 5 office buildings, an FRL of 120-120-120 for general systems and for massive systems. The DTS provisions for an FRL of 90-90-90 and an RISF of 45 minutes stipulate the use of 2 layers of 13mm fire-grade plasterboard. To achieve the acoustic performance, the wall will need to utilise either a staggered stud system or a double stud system, known as a discontinuous wall, with a 20mm minimum gap between the walls. This latter system is the preferred option due to its more superior acoustic performance. Looking at the configuration shown here, you can see if no cavity acoustic insulation is used, then the system does not meet the NCC airborne requirement, so the system is not adequate. If R1.5 or greater non-combustible insulation is utilised, however, you can see that the system now meets the airborne requirement greater than 50 and is therefore adequate with all the different stud depth options shown here. When utilising a massive timber wall system, it needs to be noted that these are proprietary systems and therefore FRL and acoustic performance information should be sought from the supplier. There are a range of ways that the acoustic and sound performance of wall systems can be improved. Isolating one side of a wall from the other, or decoupling, reduces both airborne and impact sound and serves to limit noise vibration from one side of the element to the other, providing major reduction in flanking noise. That is the sound passing around rather than through wall or floor elements. It should be noted that decoupling is a specific requirement of the NCC DTS provisions for plant and lift shafts and SOU rooms adjacent to certain neighbouring building spaces, such as kitchens and bathrooms. When using decoupled wall systems, it is also important to avoid rigid connections between the decoupled elements. This limits the occurrence of sound bridges that would otherwise allow sound to transmit from one side to the other. If required for structural stability, sound-resilient connectors should be used and should generally only be used at changes in floor level. A recommended approach to minimising structural flanking at wall intersections is to fix the plasterboard linings to the timber studs using furring channels on sound-isolating resilient mounts. Increasing the mass of the wall linings using additional layers of fire-grade plasterboard also provides an option. This can be particularly useful in reducing airborne sound transmission. With massive timber construction, consider the use of appropriate sound isolation pads between wall and floor elements to reduce flanking noise. Sealing sound leaks at the periphery of wall and floor elements, or where penetrations are made for electrical and plumbing surfaces, will also improve performance. Adding additional glass fibre or mineral wool in the wall cavities can also reduce airborne sound transmission. It must be noted though that the NCC requires all insulation materials to be non-combustible. So in summary, the minimum NCC requirements for wall systems are an airborne performance greater than 50. Ways to improve sound performance of wall systems include decoupling using double wall system, avoiding rigid connections between decoupled elements, using resilient mounted furring channels to fix the plasterboard, increasing the mass of the wall linings, utilising sound isolation pads between massive timber floor and wall elements, sealing any sound leaks at the periphery of wall and floor elements or where penetrations are made for electrical and plumbing surfaces, and utilising higher performance non-combustible sound absorptive insulation materials in cavities. For further information on wood and wood products, visit woodsolutions.com.au, the website for wood.